periphery. Let's get a double from Hubble, and they're both trouble. Not talking about the Halloween pumpkin ET look, but a matured collision. These giants are merely resting calmly after what was likely a violent merger, like this one, NGC 34. This galactic wrestling match has just begun between two spiral galaxies, and they are destined to wind up irregular, just like the pumpkin. Of note in our long-term astrobiology focus, and of star water. Half of Sun-like stars could have rocky habitable planets, and there is no way to have a forming rocky planet which must contain oxidized rock and not have the stellar wind hydrogen liberate and combine into hydroxyls and water. Let's take a stop at New Zealand because we have many times mentioned it's the most geomagnetically vulnerable populated area, definitely in the southern hemisphere. This is a confirmation paper showing once again that even in the North Island, you are at risk. It's a combination of geologic magnetism, resistivity, and the setup of the power grids in the island nation. Up next, ozone. Far more of a climate concern than people realize, far less modulated by aerosol pollution, and far more regulated by Earth's magnetic field and solar outbursts. This is what we've seen leading up to the realization that using ozone alone, you can make a shocking amount of climate predictions more accurately than with any model. The more extreme the ozone anomaly, the stronger the statistical relationship, which is a dead giveaway that the lower extreme correlations are not spurious, but real. And to properly manage this data science, one must model both solar irradiance and particle forcing, something somewhat virgin to the global climate models. Now hold that thought as we come to Greenland and find that while the periphery is melting and helping to trigger the Atlantic current and overturning shutdowns, both of which will cool the planet, the interior of the landmass continues to gain ice. At nearly 2 centimeters a year, it's actually a geologically soaring location. Back to that ocean comment I made a moment ago, a good deal of why we got warmer and why we'll cool in the future is the long-term Atlantic variability. It has been wholly modeled as being changed by human cause, but that's just because it was easy and the models had no other explanation. But as better understanding of Earth systems is found, they uncover that internal variability swings us back and forth exactly as we've seen. For over 100 years, the Atlantic and other ocean features have been in the warm the Earth cycle. Rough luck to have the record high solar activity of the last 12,000 years and record low volcanic aerosol cooling at the same time. Most people call the result of that combination global warming and have no idea why it occurred. But as the Atlantic models get it together, we can say the rest of the seas are vastly far behind, especially the Pacific. But it's not for lack of trying, it's just for a surplus of complexity, and that's just at the surface layers. The Central Pacific is critical to understand because it not only modulates the atmosphere with El Niño and La Niña, but it modulates the amount of heat stored in the ocean. I know this year we've shared a ton about bias and error and uncertainty in the oceans, but folks, this one has to take the cake. Not only do they straight out admit that internal variability could have caused everything they are seeing, no human influence, but when they run that model into the future, they somehow get enhanced warming. And to make it even worse, it's more warm at lower pollution levels than higher. Folks, CMIP6, the inclusion of solar particle forcing, and the revelations about bias, error, and uncertainty have produced a ridiculous slew of papers this year. They are all over the place, and it is getting absolutely ridiculous. So let's go to some actual science and lightning. One of the fastest growing and robust revelations about climate in the last decade is the importance of the global electric circuit and that solar particle forcing to atmospheric electricity. Cosmic rays and solar particles both enhance lightning, that's chapter 5 in our textbook, and a great confirmation here, not too flashy either. Last but not least, starting decades and over $200 billion behind, here comes the space particle atmospheric ionization models. Yeah, veteran observers, that's what it sounds like. It's years from maturity, likely a few more until inclusion by the IPCC, but when there is this much evidence that we cannot just ignore solar storms and climate change,